Hey guys, welcome to part 3 of the video. So you want to make a building structural drawing. So we had made the coordinates up to part 2, and once the coordinates are done actually, so we can move forward and create the Staad file. So let's work on that. Let's create the Staad file. So first of all, we need to make a folder in which where you need to save the file here. So this is and we will copy the folder location here. This is the folder which I have created, and here I'll do all the Staad works. And it's always good and to keep all your Staad files in one place, right? So just open Staad Pro. It's better internet turned off, so let's open quickly that way. So we'll open the Staad file, and then we'll give the locations and all, and then we'll make the coordinate. Just putting the files in Excel makes the process a little bit quicker in comparison. So once that is open, just click on new and browse the file location, and just paste it, the file location where you want to create the file, and just go metric units and then create. And after you click on this, and then this we'll have the coordinates coordinate here, and from the Excel what we'll do is just copy the coordinates nodes and then paste it here. And after this is done, go to the bottom view, it shows more accurately, and then we can have go to geometry and then add view. So before that, you can make sure match the this node geometry with the AutoCAD plan, and you can check whether this looks similar or not. So since I've already made the plan, I kind of remember for certain things, so that's why I'm not checking. It's okay according to me, but you should check with the AutoCAD plan. Open and check from here. Okay. This was a design, that's why, otherwise I would have preferred to be in the same line as a structural engineer. Just leave from leaving a command, you can click on escape. That works perfectly fine. I couldn't get many, if you watched the earlier video, I couldn't get many column to column beams as I wanted, but I managed. Let's see what the beam size comes after the design. Probably will come a little bit on the higher side, especially the roof beams. So now the next part is very important. After you have joined all the add beams, just minimize the window, and we'll go to select and select the node tools, and we'll keep the window like this. A little bit more if possible, and they open the AutoCAD, and here with the help of node tool, we'll just select the nodes where we have the columns in place, and this is the plinth level. So marking that of control, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 26 number of columns are there, and you have this height of 1.95 meter. So we'll just maximize it and go to geometry, go to option of translation repeat, y direction minus 1.95, and then just click on it and then click on OK. So then we got a very simple task of adding the beams. So we'll go to view, and we're going to just change this view to this much, and then we just go to geometry, add beams. So simple, adding from the foundation to the plinth level. So this step is pretty simple. The next step will be a little bit difficult in terms of scaling, that is adding the beams for the next floor. So but I am going to use a trick here for the next floor. Just see the trick I use. It will lead to a lot of ease in joining the columns. But let me just finish the job in hand first. Yeah, it's always recommended to finish a line. I didn't follow my advice myself, so my bad. So I'll count the bottom things: 1 2 3 4. Oh yeah, this one is remaining. That's why it's always good to yeah, 1 2 3 4 5 6, then 7, and then 8 9 10 11 12 13 14 15 16 17 18 19, and then 20, and then 21 22 23 24 25 26. So I have 26 of them. Now a trick is these things are selected, okay, and what I'll do is I'll go to right click and go to new view, and view selected only, okay, only the nodes which have the columns, that is you can just go to select node cursor. Here you can see there are, or you can just press Ctrl A. Yeah, and so 26 number of nodes have been selected. All the nodes vary of columns. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 26 nodes are selected. And what will I do is I'll just put the nodes of the next floor, okay, the next floor nodes in between them. So for the next floor nodes, we'll just go to the file, my file, and this is, since this starts end with 65, I'll start with 66, and then all these nodes, just copy this. Oh, sorry, just copy this, and then after copying this, Ctrl plus C, then right click, left click here, and then Ctrl plus V, then OK. So this seems a little bit messy. So first of all, what you do is you just finish the top floor. So go to view and just left click here, view, and go to the front view. And first of all, let's deal with this first. Select a node cursor and let's deal with this first. Right click and new view. Yeah, only this only. Yeah. So view and bottom, top view, bottom view, technically, but call it the top view. Okay, so go to geometry and then click on add beam, and then we are good to add some beams here. So this is the design, hope you remember that. Okay, this was not in the same line, I forgot that. This is a different line. This is in line with this. Okay, one thing is this one here, I need to this, I think one node is missing here, obviously. This particular column node is missing, so yeah, we need to give this node specifically. So let me just check. So this is 18 point in the line of 13.12.382, it is 18.369. so this was missing, so 12.382, yeah, this was missing actually. I'll just, when I'll share with someone, so that's why I'm just correcting this. Escape, insert. This will be actually 88, but now we'll see, we'll wait. So 18.369 3, and this is obviously 12.382, and this number is 108. So right now you just 108 it, and then copy and paste it here. Okay, but for later reference, if I'm just going to give it to someone, and then I'll just correct this one and this one also. Done and dusted. So yeah, now I've got to be a little bit careful, and this beam is a single beam, but it's not the case, so I'm just going to add this beam once again. So since I remembered this, so that's why it could be corrected very easily. So this is the structure, a bit irregular, but it's there. And now I'll save it. Okay, and then we'll go and display whole structure, isometric view, display whole structure, and then try to join like so. Geometry and add beams, and I'll try to follow my own advice this time, and you guys also follow that. Complete one line at a time. So I'm just starting from the front. This one, if I click anywhere else, they will tell me to add a node. That's why I know I've clicked somewhere wrong. So 1 2 3 4, fifth one, this, there it is. No, sixth one, yeah. Okay, this 7, 8, 9, 10, 11, 11, 12, 13, 14, 15, 16. Come on, just need to have a better view. If you rotate too much, you can get confused, like I'm waiting right now, right? 15 or 16, I forgot. Okay, let me start with 16. Okay, this is 17, then 18, 19, 20, 21, 22, 23, 24, 25 and 26 number of columns are, so that must be good. Here let me check from the front. There are 26 columns, so I'll just do a quick check. Select parallel to Y and right click and then view, right click and then view selected only, new view, just click on OK. So yeah, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26. So yeah, we're good here, view and display whole structure. So yeah, this is done. This entire process, we have completed the majority of the modeling, but it's not complete. But since it was a asymmetric structure, different ground and first floor, this was the kind of tricky part. So then we go to front view of the building, and then just click on this, and then go to geometry. This is G+1 building, obviously, so we'll go to geometry, and we'll go to the option of translation repeat, and this time we'll just click on Y, and 3 meters is the spacing, 3, right? And just add the last floor for the building, and we can in the utility have the node tools, and you have the node tools here. So to activate, the easiest way of assigning supports is, which I prefer, there are various ways. Just I want to select these nodes at once, and then go to the node tools and then just assign the supports. Obviously there will be a fixed supports which denote the connection between the column and the footing, and I have to select it again, right, and then assign. Yes. So this is the process, and go to view, and then so this is the process of just assigning the nodes at the level where the connection between the column and the foundation are. And the next important thing in this thing, situation, is the properties. So we define some properties here. Rectangle, obviously you have considered column of size 300 into 300. I told how I like this size based on the compatibility, and ZD, that is for the plinth beam, will go try to have 300. If not, this doesn't pass, then we'll go with a higher size. So 2 to 300 I want to add for the plinth beam, and 250 into 350 I want to add for the roof beam for now. If anything happens, we'll go with a higher size. So third one is for the roof beam. First one is for column, so select parallel to Y, and then assign. Next one is for plain beam. So go to view, and we select the front view, and we'll select this, right, and then assign to selected beams, assign. Next one is for the roof beams, so we'll just select this and control, and we'll select the top beam as well and assign, and yes. So this is the size here, 250 into 350, right? So after this specification has been given, then we go to your loading, right? So we need to give the loading now. So just the definitions here, done it a lot of times here, so add the definitions here. So we'll be adding here IS code, latest one for the earthquake, and click on generate. Zone, preferably zone 5, which is SMRF, always we take special movement resisting frame in the general building, medium soil, RC building obviously, and damping of 5%, generate, and click on add, and then close. Okay, then we're going to go for the loadings here. So here, yeah, I have text file. So there are first of all, let's talk about the wall load. So there is 12 kilonewton wall, 12 meter wall load for all the this things, because this is there, and for the parapet we'll consider 4. Okay, 4 kilonewton per meter. So 12 for all the beams we'll consider, and parapet for parapet 4. So we'll just add here. First of all, we'll add the self weight factor 1, and then we'll add the member weights U and I. Okay, this will be from as told in the text file. This will be 12 and 12 for some, and 4 for the parapet wall. This having said that, and then we'll go to this this joint weights is there, self weight is there, and then we'll go to the element weights in terms of the pressure. Okay, so in terms of the pressure, we have the wall load I have calculated. In terms of the pressure, we will calculate the this load of the slab, right, is equals to, that consider 0.125 mm thickness of slab into we'll multiply this amount in with the with the 25 that is the strength of concrete, unit weight of concrete. So 0.125 multiplied by 25, so sorry, 0.125 multiplied by 25, it will give 3.125. Okay, you know what, I think the spans are pretty large for some okay, no, okay, let's give this first, or we will think later of the spans. 3.125 is for the this is kilonewton per meter, and this particular load is for the load of the slab. Okay, and so this is the load of the slab, and after the load of the slab, there is the floor finish load which you consider, and there is the load on the live load considered in earthquake, LL for live load. For seismic load consideration, okay, we know that clause, more than 3 and more than less than equal to 3, more than 3. So yeah, so it is 2, so it will be 0.25%, and this 0.25% is equals to 0.25 into 0.25 multiplied by 2, and that will be equals to 0.5. So 0.5 of the live load is to be considered in the seismic load, 0.5 kilonewton per meter square. So this will be considered 0.5 kilonewton per meter square. So, and floor finish load, which you already had written, I think floor finish load is 0.5 kilonewton per meter. So load finish load is equals to 0.5 kilonewton per meter. This will cover all the tiles and marble, everything which you want to provide. So total load for earthquake, if you just combine all these things, so it will be 3.125 plus 0.5 plus 0.5, 4.125, right? 4.125 kilonewton per meter. It includes the load of the slab, load of the the load of the floor finish and all. So dead load, live load, everything is covered in here. Since we are not assigning the slab element here, that's why we are taking the load of the slab. Otherwise we don't need to take 4.125. We'll assign here directly. Since it's earthquake, there will be no negative sign, right? So you can insert this in element weight, you can insert this in floor weight, so no worries in that. So but it's better if you insert it in floor weight, right? So I'll insert in floor weight 4.125 because you can give the range here. So y range, it will start from, so this is 0, it is at 3, so it will start from 2.9 to this is at 6, so it will, let's give 6.1, right? So I'll just add this element weight, delete this element weight, right? So we'll assign this later. This is already assigned. And load case details, primary load, first of all dead load, first of all we'll go seismic load, so it will be SLX add and then SLZ in the other direction, then we'll go dead and then it will be DL, then we'll go live and this will be LL. So then we'll just add the combinations here, seismic load, so we'll go seismic in X direction, so seismic X direction factor of 1, consider the maximum, seismic Z in there is seismic in Z direction, consider 1, and I will click the add, close. Dead load, add first of all self weight, now this will be -1 acting from top to bottom, and then the member load, we already know what is the member load, -12 for all the normal walls and -4 we'll take for the parapet walls, and floor load will take floor finish plus the slab weight, so slab weight plus the floor finish. So slab weight is 3.125 plus 0.5 is equals to 3.625. So minus 3.625, y range will be same, 2.9 to 6.1. Add, and then so this will be automatically assigned. You see the blue ones, yeah. So this is automatically assigned. View, yeah, you can see this, yeah. So the remaining ones will assign later. So then live load, you click on add, and this will be obviously floor load, and -2, that is 2.9, and then 6.1, click on add and then close. So live load is also assigned. So let's assign the remaining loads. Member weight of 12, ideally we can select all the members and then only the places where you have beams, then we can apply that, but right now I'm just going to give a shortcut little bit. Okay, so just select this, I'll just select this, and then assign to selected beams, assign and yes, and for this also same thing I'll do, where this guy, assign to selected beams. I'll just select them again just to make sure. Okay, I just lost it. Everything is right. Assign to selected beams, sign and yes. And now comes the load part for the 4. For the 4 I'll just select this and right click, and then we'll go here, new view, then we'll go to the top view. So the staircase portion, what we'll do, this is the staircase portion, we'll have headroom over here. For the staircase portion we'll have the 12, good old 12. Here as well, and here as well, and for the remaining portion we'll have 4. No, I forgot, just don't need these two, right? Done. Self weight will do assign to view. Done. Yeah. So this is pretty much this loading part. Then we'll go to analysis, concrete, and then obviously select the IS code, select the parameters, clear cover, clear cover, compressive strength, press Ctrl and then select this. for beam, 104 for column, 25 and 25 grade we're going to use. Main reinforcement available 550. Maximum main 20, maximum secondary 10, minimum main 12, minimum secondary 8, select parallel to X, parallel to Z, this beam selected, column selected, beams and columns are selected here. Now go to analysis and design, analysis commands, and this command, close and run the analysis. So there is an error. You will know in a very short time that there is an error. It hanged. Okay, so there is no error. So the file has been successfully run and your process of Staad is now complete. Now the remaining thing is all the steps of RCDC. Okay, and then the drawings.